Given 3 moles of H2 and 6 moles of F2 reacted in a 3-liter flask, find the equilibrium concentrations of all species if the equilibrium constant is 1.15 times 10 to the second. This is a very standard equilibrium problem. I already have the equation, I already have the constant. Product is HF. Reactants H2 and F2. This equilibrium problem is going to be basically an algebra problem. Given the initial concentrations, which I should just write them down, 3 liters, H2 will be 1 molar then, F2 2 molar, HF is 0. For this problem, I won't even need to do a reactant quotient because all I have are reactants. It can only go one direction. So I'll go straight to making a chart then. H2, F2, HF. So I'll start out by writing the initial concentrations. 1, 2, 0. And now I'm going to do the change between this, and I guess I'll put right here as the equilibrium. This is going to be the net change. So this is going to change by minus x. This will be minus x, and this will be plus 2x. And this has to do with this equation right here. These are going to react 1 to 1, and then when these react 1 to 1, they're going to create 2. So as these things begin to react, this is going to change by x, this is going to change by minus x, and this is plus 2x. So the equilibrium concentrations for this, for hydrogen, it's going to be 1 molar minus whatever the change is. This is going to be 2 minus whatever the change is, and this is just going to be 2x. Now I'm going to take these and substitute them into this up here. So this problem becomes 1.15 times 10 to the second. It's just like a regular equilibrium problem, but I'm using algebra to give me the unknown. 2x raised to the second. Now basically there is no more chemistry involved, and this is all algebra. So multiply this over to the other side. I'll just square that. And then I already wrote this out. I multiplied it out. What did I get? I got 1.15 x squared minus x and then subtract 4x over to the other side. So this will be, I should have just done that originally. Oh well. this is an equation in the form of, write in a different color, ax squared plus bx plus c is equal to 0. So I can use the quadratic formula on it. X is equal to minus b plus or minus square root b squared minus 4ac over 2a. So I just substitute in. This is a, this is b, and this is c. Well, that's a minus, so that's going to be a plus. And the minus sign doesn't really matter, it's going to be squared anyways. Minus 4 times a c times a. So I've got to do this once for plus and then minus. So I'll get two answers, but only one of them is going to be correct. When I do this whole thing, x is equal to, I got 2.14 and also 0.968, and this is molar. Now to figure out which one of these is correct, normally one of them is, it's pretty obvious which one is. If I go back up here to my chart, I have 1 minus 0.00 minus x, or 1 minus x, as the equilibrium concentration. If that concentration were 2.14, then I would get a negative number. So obviously this one is not 2.14. It would make sense if it was 0.96. So this one is not it. But I'm not done quite yet. Now that I have my x value, I substitute them back into here. And these are going to give me my equilibrium concentrations. So H2 is equal to 1 minus 0.968 F2 and then HF. So this top one is equal to 3.2 times 10 to the minus second. The second one and then the last one these are all the answers. And then a good way to check these answers to see if they're correct is just to substitute them back into this equation. Substitute all these numbers in. Well, that one goes here, here, here. And I put these in here and it should be equal, oh, just 10 to the second. It's got to be equal to this number. So that's a good way to check. That's another way to check if I get, let's say for some reason that both of these numbers were I couldn't tell for whatever reason, or I didn't feel like doing it. I can calculate these for both of them, and then whichever one ends up being true for this number is the correct one. Because if I had solved this, let's suppose it wasn't a negative number, and I'd solved this, it wouldn't give me that number. So that's the best way to check.